Okay, so last time we have a look at this DID document, the structure of the DID document of the DID IOTA method. Just to remember the structure, there is the real documents, the properties doc, and some metadata. Essentially, metadata provide user information about when this DID document has been created and the last updates. The other particular feature of this DID document is that, as you see, the ID in the verification methods and also the controller, because this DID document represents a situation in which subject and controller are the same entity, report DID column 0, column 0. Why this? Essentially because this is a particular feature of the DID IOTA, in particular due to the working principle of the DLT, that is the tangle that underline this method, is that when you make a transaction to anchor your DID document to the tangle the first time, you don't have a priori the address where you are storing your DID. So the developer of this method decide to put DID 0, column 0, and when you resolve it, you can check that the ID of the object that contain the DID document in the tangle coincide with the specific method ID of the DID that you are resolving. So you can double check that what you are resolving is exactly what you get in terms of DID. That they want also to reduce the amount and the size of the DID document, because in real DLT transaction have a cost. And this particular DLT cost is proportional to the amount of data that you put in the transaction. So this is another reason for them to select this choice. Then they use the classical type JSON web key. And so in the verification method, you have the, they always use the Edward curves. And so a DSA. And in the, let's say, encoded public key, you have the curve and the value of the X to generate the public key associated. And in this particular DID document, they essentially provide you the information here that for authentication purposes, this is the verification method that you must use. Now, let's go maybe directly to the CRUD operation. So if you remember, specifying a DID document essentially means specify the DID format, the DID document format, and specification about the CRUD operation: create, read or resolve, update, delete, or deactivate. What is needed to create a DID and a DID document with this method on this particular DLT? Essentially, you must have an address for which the private key is available. In particular, we are referring here to your private key, the key pair for transacting on the DLT. So the pseudonym that you have to transact on this particular ledger and enough fund to create the identity object. When you see here identity object, essentially you can think about the DID document. And to issue, of course, the transaction. What are the steps? You essentially generate the DID document, you create header and payload of the transactions, and then you execute the transactions. Once your transaction is confirmed, essentially the DID and DID document is published. And so the object ID, that is the hash of the transaction that you receive back from the ledger, is the IOTA tag or the method specific identifier of the DID. That's why you see in practice that essentially the first time that you anchor your DID document, you don't have the address, but you can use it afterwards. Few more things on this. It's common that when you select a DID method that use a real DLT, that you have to handle at least two key pairs. One is essentially your pseudonym on the ledger, and so the key is essentially the private key that you use for making transaction, to issue transaction, and the key pairs associated to your self-sovereign identity. Okay? Resolve. Now that we are in a situation in which we are providing someone else, so someone else is providing us his DID, and what are essentially the, I miss another important point. There are essentially two libraries here involved in these steps. The IOTA client, that is the client agent that you use to make transaction, and the IOTA identity framework that help you deal with the identity. So in these steps, you essentially are using an agent to transact and another library, the IOTA identity framework, that provide you all the functions to deal with your with your identity. Resolve. First of all, I receive a DID. DID column IOTA, the network, if you remember, then the address on the Tangle to retrieve your documents. So you need the object ID to retrieve that particular transaction, and so the data associated to the transaction of the controller of the ID documents, and you can obtain it by extracting from the ID that you receive from your peer. You must obtain also the network of the DID by extracting the IOTA network from the DID. So you now know exactly which network you have to use and which network you have to contact to make the resolution of the DID. You make it and you essentially retrieve the transaction. At that point, you have to assert that the object ID of the return object match the object ID extracted from the DID. Otherwise, of course, you are resolving something different, and so you return an error in this case. Then you parse the object into an identity object. You assert that the identity is deleted, the ID flag is not set to true, otherwise you have an error, because you have also to check every time you resolve a DID that the controller have not deactivated that specific DID. You decode the DID document, and at this point, if the DID document still contains, sorry, DID column 0, you can replace the value with the IOTA tag from the given DID. Update. You can imagine this object as a structure that give you the right or the ability to make updates on it. You can update the data on this object, and this object maintain also the history of the different writing operation. In this way, you have an update that also take note of the history of the different updates. That's why, if you remember, where we talk about the template resolution function, you have version ID and other update IDs that let you also specify in some cases which specific version or timestamp you want to use in the resolution. So in this particular method, you have the whole history of changes of these DID documents. So if you want to update, it's very simple. You create a new object ID, you update the document, you create a new object ID, and then you transact this update to the DLT. Very simple. Now we have two options for delete or deactivate a DID and a DID document. The first one is just to set the identity object before making the transaction to an empty byte array, such that when someone else is going to resolve our DID, have a clear information that the controller has deactivated the DID. Or you have also property in its metadata that can you set, for example, the activation flag that we see few slides before, such that again the resolver knows that this DID has been deactivated. There is also another option if you want to permanently delete IDID documents. Essentially, you ask for receiving back the deposits, so the few tokens that you put on the network to make this transaction permanent. At that point, after a given period of time, the working principle of the Tango will prune the last value, and so you permanently delete your DID document from the whole data structure of the DLT. But in principle, you don't know exactly what is the time that pass from bringing back the deposit when the DID document is effectively deleted. So this is why normally the activation is the preferred way to delete, deactivate the DID document. Now, every single DID method specification provides us some further information for us to consider when we want to deploy, to use and deploy the specific method. And these further information are security and privacy consideration. And of course, they change. They are quite the same method by method, but they change in terms of numbers and what the developer of the method really want us to take into consideration. This particular case, the security considerations are more or less super simple. So take care of your private keys. Okay, we know, we'll do it. Privacy consideration. First of all, consider that under, let's say, the normal operation, the DLT, the tangle behind this method provide you real immutability and persistence. We talked a few seconds ago about the activation, and I told you that in some cases you can also let the tangle prune your transaction, but please take into consideration that anyone on the network can deploy some special nodes, nodes of this distributed ledger that are called permanodes, and they essentially don't prune all transactions. So permanode maintain the full history. So you don't know who, where, but someone can take the whole history of the transaction. So that's why the activation is in some sense, the most safe operation that you can do to create the cryptographic evidence that you as a controller wanted to deactivate your DID. Okay, so they inform us that some permanodes can be deployed, and so we need to consider and take this into consideration. The other one can very simple, avoid the use of personal data in the DID documents. If you remember the general privacy consideration that we address when we talk about the DID specification from W3C, also they warn us to avoid also the use of not to use algorithms to encrypt data because they can become obsolete on the time. And the other point is linkability. So they also consider linkability and suggest us essentially to use pairwise DID where possible to avoid linkability at DID level. That, just to remember, it is possible not only when you look at the DID itself or the ID in the ID document, but also in metadata. So if we don't change frequently let's say, if the normal working principle does not change frequently the metadata, sometimes also the signature, so whatever, in documents, this can be used for linkability, no? To by collude, node that collude to exchange the information. Any question on this method? No? Okay, so this was just one example, because there are diverse and different and several methods that use a DLT. This was just an example. Now we go through the example of a method that fall in the second class of DID methods. So essentially DID web, a method already specified that use the web infrastructure as the VDR of the method itself. Now, why a different class of DID method? Essentially because there is no a single or very few DLT on which the whole identity community is converging. So sometimes it's anyone want to take his own decision. Anyone has their own preference. So someone prefer a DLT, maybe others don't like it for any reason and want to use another one. And even if the ID specification let us use different DLT, so peers can use different DLT when they exchange the information and open this first trust interaction. In general, there are part of the community that think that will never be a single DLT that everybody want to use for anchoring their own identity. And so they, starting from this consideration, decide to specify a new one that use maybe the single and only infrastructure that everybody is using on the planet today, that is the web infrastructure. So the ID web use the web infrastructure, allows any subject to manage the ID using existing web domain, of course, without requiring a DLT. And this method leverages standard HTTPS and DNS infrastructure for DID operation in general, DNS in particular for resolution. What are the requirements? Of course, a web domain under your control, or a web domain that with any other function out of the scope of DID web specification let you use the domain itself for building your identity. You must be able to host file on your web server, of course, or web server or someone else give you the right to do that. And you have to enable HTTPS. The target system of this DID is, of course, either the host name or the domain name when the DID is resolved through DNS. let's see some example. Root domain DAD. So essentially, you are using the root of your location. So DAD web colon dev web colon example.it. So essentially, the location of the DID document is https example.it. At that point, you have to create a .well-known folder, and you put your did.json file containing the DID document. So this DID essentially refer to this target system. The root, in which we have a .well-known folder and containing the did.json file. In some cases, you can have a subdirectory did. So did colon web colon example.it colon department A, just really as an example. So this means that from the root, you go through the folder department A and you put your DID.json there. There is no need for the .well-known folder. There is also another option for this DID, that is the deep path DID, in which after the domain name, you have, for example, further information, users and Bob. So the location of the document will be, there is a typo here, so imagine this .it, example.it slash users slash Bob, and there you find the did.json file containing the DID document. Okay, and this is the DID document specified by this method. Let's say the general structure is, of course, the one specified by the DID specification from W3C. So there are essentially 4 information. In this particular example, we have 3 of them. The context. In fact, if you look at this, the context is still version 1.1 of the DID specification. DID, in this case, DID colon web colon name, and the verification method with ID, type, controller, and in this particular case, the DID web method decided to use the JSON web key type, and so public key JWK for specifying the public key. Of course, you can add service. If you remember, there is also the property service to provide information to the resolver about where the URL to contact for starting interaction with a particular service. So let's go through again the CRUD operation. In this case, create is simple in general term, but require a lot of attention in terms of giving the right authorization to the user to store the DID. Why? Because you essentially have to create your DID document and you store the DID.json file under the well-known URL or in some subdirectory based on the kind of DID that you want to create. This is super simple, but you have to imagine that you have a single web server. On one side, you interact with your identity. On the other side, you must have in place any authentication, authorization system that is completely out of scope for the self-sovereign identity, give you the right to store data on the server, delete data. So this method does not consider all the authentication and authorization function that the who is hosting the service, the owner of the server, for example, must to put in place to control who is going to store the DID document in this VDR. Okay? So if we consider the system looking only in the domain of the self-sovereign identity, you essentially have a web server and you can resolve the DID with the DNS and retrieve the DID JSON file. But when you build and you update your DID documents, you interact with the same server, and in this particular case, the method for authentication authorization can differ from SSI. Can be classical username or password or any other option that the owner of the domain and of the hardware infrastructure put in place for you to control your identity. This part is outside the scope of DID web specification. You get the point? Okay. Resolve. So you receive a DID, and first of all, you replace column with slash. In the method specific identifier. You prepend HTTPS column slash slash in front. So we are parsing the DID received, okay? If no path has been specified in the URL, you append slash dot well known, because that will be that is essentially a root DID, and then append slash DID JSON to complete the URL. So we are parsing the DID to create the final URL that you have to contact after, of course, using the DNS to negotiate a secure HTTPS connection and retrieve the file did.json. At this point, we have to verify that the ID of the resolved DID document match the DID. if we go back to the example, we need to parse the DID into a URL. So we replace colon with slash, we prepend HTTPS colon slash slash. If there are no subdirectories, we add dot well known, and then in any case, also if there are other subdirectories or deep path, we add slash did JSON. This give us with an HTTP request to retrieve the document. Update. Simply store the new DID JSON in the right path on the server. Update, as for the create, require you to authenticate and be authorized to do that on the server. Again, how to deal with this authentication and authorization is completely out of scope of the DID web method specification. Delete, in this case, we can really delete a file or make it no longer publicly available. Security consideration. These are, again, the consideration that the developer of this method provide us to take care of what is, let's say, around the method. Authentication and authorization. So we need to protect with best practice solution the web environment. In this particular, with this particular consideration, they are referring to the fact that you, as a controller of your DID document, interact with the web server, let's say, outside the domain of the self-sovereign identity. Of course, a web server is not a distributed ledger. So in this case, immutability, we have persistence if we take care of the information, but not immutability. Or in anyway, we need to control the integrity of the DID JSON file. They suggest, for example, to have an hash of the document and store it on an immutable VDR. So they are suggesting you can store the hash of your DID JSON file, essentially of your DID document, on a DLT. There are also other options. Which one? I think you have already addressed the TPM, for example, the Trusted Platform Module. How can you use it, for example, to deal with this? My question is slightly different. It's different. So how can you, for example, use the TPM to control the integrity of this JSON file? Essentially, you consider the measurement of this document, and the remote attestator or verifier can check periodically that the hash of the file didn't change. or any other solution that you have in mind to check periodically the integrity of the of this file, of the DID document. Because if an attacker can take control and becoming the wrong controller of the DID documents, can store whatever public key he wants and use the associated private key. Okay? Now, also, we are using the DID essentially as a means for in challenge and response algorithms to verifying that the peer is in control of the private keys associated to the public key stored in the document. But pay attention when you deal with this method that proof of control can refer to host name, domain name, or user if you use subfolders. For example, in this case, DID web name.com user Bob. Proof of control refers to Bob and not to name.it. Okay? That's very important because maybe the owner of the domain give you the right to use your subfolder, and so someone else need to pay attention that you are not you are interacting with this particular user and not the whole domain. There are a lot of literature in for DNS attack. So essentially, man in the middle and redirection to malicious server. So that's something that you have to consider, and you must be secure that you put in place all the countermeasure, because that's a possible attack. And for what regard in transit security, TLS 1.3 last version is the one that we have to use when interact with the server. Privacy consideration, more or less are all consideration deal with tracking and linkability. The owner of the DNS service can track you, and essentially every time you resolve the URL, he can maintain and track all the DID that you want to resolve, and the same at the server side that contain the DID document. So linkability is an issue with this method. If you're in your, let's say, the application that you want to deploy that use this specific method for security, for identity, need to consider these privacy issues, and if they are, let's say, relevant, take the proper countermeasure or not. It depends. But you must be aware of these of this issue. Question? Clear? Okay. Now, another example of that fall in the third category of DID method. We'll go through the specification of DID key that fall in the class of key-based method. Essentially, those DID method that doesn't use VDR. Okay, so DID key method is a DID method for short, lasting, and static keys. We don't use VDR with this method, essentially because we encode and then expand public key into well-known DID document. So the DID is DID column key column multi-base value, where multi-base value is a multi-base base 58 BTC encoded value. It is the concatenation of the multi-key identifier for the specific type of public key and the raw bytes of the public key. It's not super easy to understand the first time, but let's go through and specify what does it mean. For example, these are the table that provide us the multi-key identifier. So MB value is a multi-base base 58 BTC encoded value. It is the concatenation of the multi-key identifier. So let's go through the multi-key identifier. For example, Edward 25519. The encoding of this public key must start with a 2-byte prefix, in particular AD01, followed by 32 bytes public key data. And the resulting 34-byte value are then encoded using base 58 BTC alphabet. And then you put in front the header Z. So essentially, we are encoding directly the public key into the DID directly. That's why we are, let's say, with this method, we don't need a VDR, because the public key is in the DID. Let me show you an example. This is, for example, the specific method identifier. Okay, so this string is the encoding of the multi-key identifier concatenated with the 32 byte of the public keys, encoded BTC 58 base 58 BTC, and with Z in front. Just an example. If you, for example, the code, that's the value, okay, of the DID. If you remove the Z in front and you, for example, decode it, you see that the first 2 bytes are AD01 as specified in the multi-key type, and then the 32 byte of the public key.
Since encoding being less secure, than why we can use write key inside.
Because are completely different purposes. The idea here is just to, we don't want to encrypt the public key. We just want to encode it, put in the DID to provide this information to someone else. Encryption is not required, and we don't need it. We just want the public key is the public key. You can it's public. There is no reason to encrypt it. I want just to encode such that everybody that receive this specific DID knows how to decode the type and how to decode the public keys. So a standard encoding solution to provide the information to someone else, to your peer, essentially. So encryption is completely out of the equation. You don't need it.
Yes, but this method uses VDR.
Yes.
What about tampering protection?
Let's go through the operation. Let me share again the screen. Of course, you can use different public key type. So we made an example with the Edward, but you have also the encoding also for SCDSA with 256 bit or 384 bit, and also with other public key type. But essentially, what changed between one and another is the prefix, the 2-byte prefix, and then you use the same coding and decoding algorithm. And all 5 specified use the header they in front. So essentially, we exchange the ID just to try to answer you with more information. Why we exchange the ID? Because we want to let a peer knows our public key. With the first 2 methods, we store the public key in a VDR, immutable, DLT, non-immutable, web infrastructure, whatever, and give a pointer to this public key. This particular method don't use a VDR, so it's very important that you use this for short lasting keys and static keys. So when this is the purpose of your let's say this feature fit with the purpose of your application that is using this particular digital identity solution, you can use it. And with this method, we simply provide directly with the DID the information about our public key. This is an example. And create a DID in this particular method means generate a key pair and then to encode the public key with the base 58 BTC encoding algorithms. We encode, we put the header in front, and this is our DID that contains directly the public key. What does it mean resolve? So the peer that receive the DID, this particular DID key, knows that the method key requires to expand the keys into this fixed DID document. Okay, so I know that if I receive a DID of type key, this is the DID document that I have to expand my DID in these specific DID documents. And let's go through it. Of course, the context, again, version 1.1 of the DID, at least today, of the DID specification. The ID of these particular DID documents coincide with the DID key. I have used the same example in this particular DID. Then the verification method with the same ID and a fragment. This is, of course, a multi-key type. The controller, I know that when someone else decides to use the ID key, the subject and the controller in this specific case coincide. So I generate by myself this document, putting the same DID as a value of the property controller. The public key is public key multi-base, and that's the key. Okay? Of course, at the beginning, there is still the header, Z, and the 2 bytes prepended. So when I really want to use the public key, I have to remove them and the code and remove those information to really have the public key. The ID key is only for authentication. So the developer of this specification decide to use it for authentication, in some cases also for assertion. If you remember the exercise we did the first lesson on this topic, we can specify a generic verification method and then inform our peer that for authentication, in this case assertion method, that's the same key. Of course, this method does not support update. And as you can simply imagine, does not support the activation. So I can use this method only for static keys because I can change them, and short lasting if I need it for let's say super fast interaction, and then I want to forget about it. What are the security considerations that the developer give us? Of course, key rotation is not supported because if I want a new key, I have to generate a completely new DID. The activation is not supported, so I have to use it I have to remember this, and so pay attention when I deploy this method that a certain point I can use it only if we can forget about the keys, essentially, because I cannot deactivate it. And so they suggest to use it only for short lasting interaction. this method does not provide any consideration about privacy. Now, if you remember, when we started talking about the DID method, we specified some indicators to compare the three solutions. Essentially, immutability feature of the VDR, performance, cost, and CRUD operation. So let's use these indices to compare the three methods. So we essentially went through three completely different DID method. One that use a DLT, in particular a really DLT that provide us immutability. So with this, we essentially can we have a simplified life in the sense that the VDR provide us immutability, in some cases also persistence. If not, we have to consider this in the solution, no? But, and these are the methods that that fall within the class of DID method, but not all DLT provide, let's say, real immutability. Sometimes the overlay that provide you access to the DLT implement some caching solution, or maybe other overlay that are in between the who is transacting and the DLT. So please consider it, because you cannot consider to have real immutability of the DID document if this is not the case. So consider this. Only in the DLT-based class of method, for sure, you have to add further solution for immutability, for, let's say, not for immutability, but for integrity of the DID document in DID web like solutions. You don't consider immutability in DID key. So that's more or less the difference between the three classes of methods. If I have a real DLT and I can directly transact on the DLT without any overlay in between, I can say, okay, I'm in a situation in which the DID document is really mutable. If I use in DID web, I have to add some further information, some further function for protecting the integrity, or at least being informed. But when me or someone else change the document itself, we persistence. Some DLT give you also persistence, others not. You have also to consider this, because maybe you have to refresh your keys, or essentially your DID documents. Persistence is guaranteed if you do things well with the web infrastructure. So solution for solution, we have different features in terms of immutability and persistence. Performance. With DLT is super fast to read typically, but very slow the writing. So you have to consider if your application, specific application, need, for example, fast DID generation and publish, DLT is not the best solution. For sure, on a static, on the web database, is much faster to write, and sometimes is very slow the reading operation, so the opposite. So this is also something that you have to take into consideration. with DID key, super fast. I give you the key, the DID that is an encoding of my public keys, and you can, because you know the rules to generate your DID, the DID document, you can generate very, very quick. Cost. DLT require funds for transacting, so to store and anchor your DID documents. The single transaction, and sometimes these costs depend on the amount of data, so the size of the DID document. So consider if you or the user of your solution are willing to pay this cost. Typically, you don't have cost in terms of SSI operation to use your web infrastructure. No cost at all if you use the CRUD, if you use the DID key like method, because you directly provide your peer the public key. CRUD operation also really vary from one solution to another. For example, in DID key like methods, update or deactivate are not supported at all. In DID web are very simple, but you have this further authentication and authorization mechanism that you interact with when you want to create your DID document, essentially your DID.json file, update it or delete it. In DLT-based method, you have all 4 operations, but we cannot talk about real delete, but the activation of the DID document, essentially of our public key. Why? Because not all DLT really provide us a way for delete something. We went through the IOTA solution. There I can, for example, leverage the pruning operation of the tangle. Others doesn't have any solution for real deletion of the document. Okay, so we arrive at the end of this, let's say we address VDR, DID method, and DID, the first 2 layers of the self-sovereign identity framework. We can now have a short break, and then we start with the verifiable credential layer. Okay, I take the opportunity to answer one of the very interesting questions from one of your colleagues, and I want to give the answer to the whole room. So the point of the question was very, very interesting. We are using HTTPS, DID web, okay? So we are using HTTPS. This means that the server side need a certificate. Okay? Okay, and so the question is, and so what? Why we are discussing an SSI method when in the end, for using the web infrastructure, we need also the certificates? And that's a very, very good question. And a question that I made myself many, many years ago also. That's the point. Self-sovereign identity is an application layer digital identity solution. When we adopt self-sovereign identity in any, let's say, web scenarios, I'm not talking about the ID web in general, for authentication over the web, there is no way to avoid the use of certificates at the server side. Okay? For sure. Because no one has the power, also with a very good technical solution, to, let's say, push the whole internet community to remove certificates, because they works. Okay? So this means that when we use self-sovereign identity to authenticate ourselves on a web service, we can use TLS and the TLS handshake with server-side authentication. Only server-side authentication. Of course, based on certificates. Then, on top of this secure channel, we can use self-sovereign identity for client or user authentication. So we, in the end, have mutual authentication, but on two different layers. One of the last topic of this module will be something we work on 2-3 years ago. And so we ask ourselves exactly from this point. So I thank you for the question. And we say, but if we are in a totally different environment, for example, an IoT system, okay? Why I need to mix certificates and self-sovereign? And so there we made a very, at least to me, very interesting work and a scientific publication on using verifiable credential, so self-sovereign identity solution, as a certificate type in TLS. So in connected system, in particular IoT system, where there is no reason really to mix these two types of identities, we upgraded the TLS implementation to use verifiable credential as a further certificate type. You know that with TLS you can use certificates, raw public keys, and also other options. So we added the verifiable credential, and so in that case, we reached the mutual authentication or one-side authentication only with self-sovereign identity. So we essentially made a work on adopting, slightly changing and adopting a application layer identity solution in the lower layer of the stack. But we will go through this work really at the end of the module. So thank you for the question. You are right. In this course, we can consider self-sovereign identity as an application layer identity solution. And so in web scenarios, certificates still stand, and we are going to use them for server-side authentication. Now, verifiable credential. Verifiable credential are we are dealing with the dirt layer of the whole framework. If you remember, your self-sovereign identity is the composition of 4 components: a key pair, a DID, the ID document, and at least one verifiable credential. The verifiable credential is a new technology with a specific data model, again, are JSON files that express a set of claims made by an issuer about the subject. What does it mean? You are not a DID, you are not a DID document, you are not a key pair. So the verifiable credential is a credential, a digital credential, nothing different than the physical credential that you have in your pockets, drive license, ID, passport, okay? But digital. That really describe you. If you remember the needs that we set at the beginning, the requirements for the kind of digital identity that we are looking for, we say lifelong, secure, that provide a rich description of your identity. Verifiable credential fit with this and meet these requirements. There is a specification. So DID are specified by W3C. We are now at version 1.1. And you see these in the context of DID documents. Verifiable credential, we are now at version 2.0, already specified by the verifiable credential working group in W3C. And the specification describe the data model of the verifiable credential, extensible, again, if you remember, the ID specification had design goals. Among those design goals, there were extensibility, and also we care, a lot of care. These recommendation give us the opportunity to extend the common, the basic data model. How verifiable credential can be secure from tampering. The name verifiable credential means something very, very important. A credential is something that describes you as a subject. The issuer make the credential a verifiable credential because the issuer sign the credential. Okay, so we can use the term verifiable because the issuer sign the credential. Then, how to generate a verifiable presentation from one or more verifiable credential, and how to present this verifiable presentation to verifier to prove our identity. Let's make it super simple today. You have a verifiable credential signed by an issuer. You can create your verifiable presentation that is a wrap of the verifiable credential signed by you, the holder of the verifiable credential. And then the model of exchange of this verifiable credential, that is a three-way or two-way model. Three and two-party models. The one that I presented you in the framework that is the most common is the three-party models. You have issuers, typically more than one, that issue credential to the holder. Holder can hold and own one or more verifiable credential and produce verifiable presentation, essentially wrap verifiable credential and sign to present them to the verifier that has an implicit trust with the issuer. What does it mean, this implicit trust? The verifier, we will see step by step, need to verify the whole verifiable presentation. That means a lot of things, plus verify the signature of the holder on the verifiable presentation, and of course, verify the signature of the issuer on the verifiable credential. Not only the verifier need to know also the schema of the credential. And that's something that, if you remember, the issuer publish also on the VDR. But in doing this verification, the verifier interacts directly with the holder, but does not interact with the issuer. This is what is meaning for an implicit trust. So you can trust or not an issuer. If you trust it. You know his well-known DID. That means you know his well-known public keys, and so you can verify his signature on the verifiable credential an holder is presenting you. But you don't have any interaction with the issuer. In some cases, but we don't consider these in this module, you can also use verifiable credential and zero-knowledge protocols or algorithms to create, instead of verifiable presentation, directly proof, zero-knowledge proofs that you can use to authenticate yourself with a verifier. What does it mean? That essentially you can provide the proof of your identity without the verifier knowing all the properties of your identity. But this is outside the scope. But just to say, in this module, we consider plain text verifiable credential. Means that when we present those verifiable credentials to verifier, the verifier knows and can read and have access to all the properties of the verifiable credential. But zero knowledge is an option. Okay, that's the typical three-party models. And you can imagine from this very first and simple explanation that there is a huge, not yet solved open point. How can a verifier decide which issuer to trust or not? There is no solution to this in the specification of the verifiable credential schema. This is really an open point and depend on the specific application and deployment that you made. You can trust Polytechnic of Torino, for example. So you know exactly the DID of the Polytechnico, so you can always retrieve its public key. You can trust the agency that provides driver license. But if tomorrow I start an issuer service, there is no standard solution for you to trust my service. Okay? We will address this, but just to know, again, also at this layer of the world framework, there are open points. Not only, few minutes ago, we have a look at the VC specification, last update, May. 2025, correct? Is changing because the whole community is working on it. As for the DID specification. Again, in this module, we go through the core principles that are, let's say, it's very promised to be the core also tomorrow. So, at DID layer, there is this peer-to-peer interaction between two peers that want essentially to verify that the other party own the private key behind the public key resolved through the DID. This peer-to-peer model is in between holder when the holder interact with an issuer and between the holder with the verifier when the holder decide to interact with a verifier to authenticate himself and have access to a service. So this peer-to-peer model still stands and is between holder and issuer and then between holder and verifier. This means that in the verifiable credential should be a very and key information that is the DID. What does it mean? That a verifiable credential, an issuer put your DID into a verifiable credential after, of course, checking that you are the owner of that DID. And when you present your verifiable credential to the verifier through a verifiable presentation, the verifier retrieve your DID from the verifiable credential. So there is in the, let's say, in the previous slides, you can think that there is a real exchange of DID. There is no a real exchange of DID directly, only you don't exchange really only the DID. You exchange verifiable credential. The verifiable credential contain the DID. This is how the two layers are interconnected. Okay? But we will see in very specific way how the data model of the verifiable credential is. Other option, two-party models, is an option. In this case, issuer and verifier are the same entity, and so you receive a verifiable credential from from an issuer that is also a verifier when I represent the verifiable presentation back. I didn't see many real implementation of this model. One very interesting is, for example, when these credentials are used for controlling the rate at which an holder can access a specific service. So sometimes the identity is used in this specific system just to shaping the frequency of an holder that is interested in accessing a service provided by the same entity that is issued and verified. But possible, let's say, the common models that we consider from now on is the three-party model. So, roles and information flow. Again, at the core, there is the verifiable data registry. A verifiable data registry, we know very well, maintain identifiers in our case, decentralized identifiers, and schemas of verifiable credential. Because even if you trust, for example, Polytechnic of Torino, you must know when you validate the credential, what is the schema of the credential. And so typically issuer use the verifiable data registry just to publish the schema of the credential, such that any verifier that trusts the specific issuer can knows how to hold the properties and can check and validate the credential. In my opinion, there is one information missing in this graph. Beside identifiers and schemas, typically there are also information for dealing with revocation of verifiable credential. But we will see. Issuer issue verifiable credential and interact with the VDR because they, of course, verify the identifiers. Just for you to know why they are using here the term identifiers and not DID. Just to make it, let's say, more complicated. DID are just one option for identifiers, but this regulation, this recommendation consider and talk about specific identifier. If someone else tomorrow invent a new identifiers, the verifiable credential should work. Essentially because they like to have this wall framework in which each layer is totally independent on the other ones. Okay? But when you read identifiers, you can translate the IDs. So the issuer verify identifiers because if I, as an issuer, beside adding my claims about your identity and credential, I have also to put your DID, I enter in contact with you and I want to control and check that you are the real controller of that DID. And publish schemas and use schemas. Issue credential to the holder. The holder acquire credential, store credential, and present verifiable credential to verifiers. So an holder need a technology. This technology is what we call at the very, very beginning a wallet to interact with the issuer, provide his information, his identity information to the issuer such that the issuer can check, to receive verifiable credentials, store those verifiable credentials, and present those verifiable credentials to any verifier. That means taking is one of the verifiable credential wrap in a new JSON and use his identity private key to sign. Of course, the holder use the verifiable data registry to register his identifier or DID and to use schema, because also the holder want typically to check that the verifiable credential still issued by an issuer is correct, is valid, and authentic. Holder send presentation to verifier that go through the whole process of validation, and again the verifier use a verifiable data registry to verify identities and schemas. And I would like to add also revocation information. So you see the central role of the VDR also in this layer. Verifiable credential consists of several information. The most important information about the subject of the credential. We will see the data model, and we also have opportunity to extend with any property we want to describe, also with common language, the identity of a subject. For sure, one of the most important information in the field of the credential that refer to the subject is the DID, the decentralized identifier. Information about the issuer, very important. Why? Because when a verifier receive a verifiable presentation, unwrap the verifiable credential and need to know what is the issuer of this credential, such that it can then go through the whole chain of steps for validating the credential. Information about the type of credential. Is a verifiable credential? Is a verifiable presentation? What kind of verifiable credential? A degree credential issued by Polito? Any type of credential. Information about the properties asserted by the issuer. So if I describe your identity as an issuer, I first of all need to check that those claims are true before putting them in a credential and signing. This immediately should make a warning in your heads. This means that in several cases, and this is another big open point of this technology, you need to check those identity properties in the real world. If I need to put your name, your address or any other information within the credential and I'm the issuer, how can I do it now? I need to see your physical ID. Okay? So again, based on the context in which we are going to deploy this framework, also another big open point is how the issuer can control and then assert the claims into the verifiable credential. This is easy, for example, in IoT system. In IoT system, typically the issuer is service already deployed by the administrator of the system itself. And so before, for example, deploying a new node on the network in lab, in secure environment, I let my object interacting with the issuer, they exchange some information, and then the issuer provide the credential to the object. This is not true in all the human settings. In human settings, some of the information must be verified also in the real world. Consider this, because this model in some way is not fully an informatic model. There is a part of operation that must be done in the real world. Also, what information about properties are set by the issuer also means information on how me as an issuer have checked your identity. No? Something about the process that I followed to check the properties such that then I'm really able to assert the claims in the credential. I asked you to provide me your physical ID. I don't know. I accept your auto certification of your information. It depends. And also information about constraint on the credential. So the credential is made for a credential can be your identity information, but can also be the coffee bar card. It can be anything. Okay? That's the good of this technology. You can use verifiable credential for any purpose you want. But you have to consider to put all this information very carefully inside the credential. You must deploy your verifier and let them really understand what they are validating. Okay, this is the simple representation of a verifiable credential. Some metadata, the claims, and the proofs. Proofs made by the issue. Subject and claims. Something that I think you now know very well. A claim is a statement about a subject. And claims are expressed using subject property value relationship. Nothing different from the IDs. The difference is that we have more freedom and more properties that we can use to describe the credential and the claims about the subject. Now let's go through the whole data model of a verifiable credential. The first is again the contest. In this case, the contest today is the credential, verifiable credential recommendation version 2.0. And essentially we are telling the holder or the verifier which terminology we are using to understand each other. The typical reason behind setting the contest between two peers that are interacting. Then the ID. The ID in this case is the unique identifier of this credential. Just as an example, this is the verifiable credential 235 issued by Polytech. Okay. The ID is the unique identifier of this credential. Is an information to uniquely identify this credential. Then the type of verifiable credential. The property type is an array of value. Verifiable credential is always verifiable credential. So in verifiable credential, the first information is always verifiable credential. Then you as an issuer have the freedom to define a sort of subtype. So which kind of verifiable credential? In this example, a degree credential. Polytechnico decide to issue credential with information about the degree achieved by a subject. So verifiable credential is still there. The second value depends on the specific credential that this issuer is issuing. So type. Then the issuer. So the property issuer define which issuer is issuing this credential. You can have you will see typically two options. Can be an URL that identify the issuer or a DID. So in this second example, for example, you will have the well-known DID of Polytechnico of Torino. Otherwise, you have a URL and you know issue number one among the set of issuer deployed by Polytechnico of Torino. If you look at these very first properties, there is not so much different with the DID because you have a contest, you have the identifier type, and then an information that essentially provides you the door to the public key. But we have more properties. Others, absolutely optional, are in the those name and description are specified, are in the recommendation. In real deployment, I saw them maybe never. In any case, there are possibility to use them. Name and description that you can use within the issuer property. So the name of the issuer and a generic description of the issuer itself. So then valid from and valid until. These information are very important because credential, verifiable credential may not lasting forever. Maybe imagine this is a ticket. There is no reason to make it valid after the date of concert, for example. Or maybe I won't give you the opportunity to authenticate to a specific service, non so, movie streaming service, only for a period of time for which you have paid your subscription. So you can use valid from and valid until. Valid from in the previous recommendation, valid from were created or issued. In any case, is the time at which the issuer signed the credential before giving you back. Valid until define essentially the expiration. Take care, expiration is different from revocation. Okay? Expiration is that the time at which a credential is not valid anymore. Revocation, say, okay, this is revoked. Maybe valid until the time and date is not reached, but you revoke the credential. So valid from and valid until. In these specific formats, you define the date and time. And then the credential subject. Credential subject is a properties within which you can fully describe as you want the claims about the subject. The important point is that you put there, after verify that the subject is also the controller on that DID, you must put the DID, because this information is how peers exchange the information of the DID such that anyone can resolve the peer DIDs and retrieve the public key. But what you put here is absolutely your decision, the decision of the issuer. Of course, you must define a schema, you must publish the schema on the VDR such that a verifier that trusts you can also validate in terms of schema the information and the data model of this credential. If you remember, at the beginning of this module, we also recall a bit the difference between authentication and authorization. Authentication, essentially, you authenticate someone else, checking the validity, the authenticity of this credential, essentially also checking the signature of the issuer on the credential. But authorization is something that happened just before, after authentication, and in this framework, authorization is checked against what is written in the credential subject. Essentially, the description of your identity. You have an authentic verifiable credential. I trust the issuer of your verifiable credential. I can authenticate you, but then if I'm the service provider, I authorize you to access a given set of resources or not based on what is written in the credential subject. Then, credential status. Any identity framework is not an identity framework if does not consider and does not provide you the proper function to deal with the revocation of the credential. Credential status is the property used to deal with the revocation of the credential. The credential can be authentic, but revoke. And so I don't give you access to, I don't authenticate you and don't give you access to the resource you want. This version of the recommendation define a very straightforward and clever way to deal with the revocation, essentially with a simple bit string. So you have an array of bits set to 0 if that credential number, for example, 235 is not revoked, 1 if revoked. So since me as a verifier, the bit string is also super simple to be zipped, because in identity, let's say in a real situation, we hope that the most of the verifiable credentials are not revoked. So I have user that can, let's say, live in the environment and interact with their credentials, so I can zip them very well. And I can simply check me as a verifier immediately, because I retrieve back this bit string. I can check if the credential that an holder is present in me has been revoked or not. And so credential status essentially have the properties ID that coincide with the unique identifier of this credential, the type of the solution that I'm implementing for dealing with revocation. In this case, the recommendation define bit string, status listen, status purpose revocation. This means that when you read this bit string, you can consider this information only for revocation. Okay, one important point in identity, but in general, when you use any type of information for providing a way to others to act, is that you clearly define what are the purposes of the information that I provide you. Okay, so it's very, very important to tell, hey, this bit string is for you only to check for revocation. Don't use this information for any other purpose, because it's not true. Okay? And in this particular situation in which we have a new framework that is evolving day by day, it's super important to define exactly those information, otherwise it's a mess. So there is no possibility to real interaction between the users. So why? So what is the purpose of this information? Revocation. The index in the bit string, I have to look for this particular credential. So in this example, again, 235. And where I found this bit string, the URL. In some cases, so essentially we are using the web infrastructure for storing and give you information about these bit string. So the same reason and discussion we had for in the ID document, for example, for the ID documents in terms of integrity, mutability, and what persistence of this information that we made for the ID document still stand also for this particular bit string. So if you decide to use the web infrastructure, you have also to, as an issuer that controlling this information, to take all the countermeasure and act to protect directly this bit string. Otherwise, someone can tamper with it. In other cases, there are some solutions that decide to leverage the immutability feature of a DLT for storing those bit strings. And so here you will have the DID of that particular resource. Okay, the ID can also be used to point to resources different from the ID documents. No, I retrieve back the bit string because I don't want to implement further security measure for integrity of this very sensitive information, and so I prefer to use the DLT. Again, freedom means problems to consider and solve. If I say you, well, that's a very smart way of checking for revocation. Super simple, super fast, but What about privacy? Again, this is the classical information that colluding verifier can use to link me. Because this information doesn't change. I always present the same information. So it's not, for example, this approach is super fast, but not privacy preserving. There are options, just for you to know, in which instead of using bit string, the verifier use different privacy preserving solutions. Essentially, if you want to deal also with privacy, you must avoid the use of static IDs that immediately point to you. Okay. Some few words about the revocation. Issuer maintain the status of issued credential. Also, what are the purposes for revoking a verifiable credential? And who can revoke a verifiable credential? Purposes can be any type. The issuer can directly, on his own decision, decide to revoke a credential, informing or without informing an holder of the credential. Can also be the holder that decide and ask the issuer to revoke his credential. This can happen. The credential can also expire. So, not valid anymore, not for revocation reason, but because valid until it's expired. The status is in the form of a simple bit string. When a single bit specify a status, revoke or suspended, also possible. The recommendation give us the option also to use bit string for suspend temporarily some credential. This means that here the purpose is not revocation, but to deal with the suspended credential. The status is expected to be true when the bit is set to 1 and false when unset to 0, means revoked only if the bit is 1. As I told you, one of the benefits of using bit string is highly compressible data format, since in the average case, what we expect is to have much more unrevoked credential. Otherwise, we are building a system, a useless system that deal with revoked credentials. So we expect to have few numbers of revocation, and so you can zip very well this information, this bit string. The last also for today, the proof. The signature of the issuer on the credential. Proof properties have some sub-properties. Type from version 2.0, the type is 1 and data integrity proof. Full stop. Crypto suite. Again, me as a verifier need to know how to check this proof. Please tell me the crypto seed that you use to make the signature. We will see also some example of crypto suite that, again, W3C is specifying. The name of the suite, created, it is the time at which this proof has been made. This means that created in proof and valid from in the metadata section can be the same, or at least valid from is after created in the proof. Verification method. So if you want to verify this proof, this is where you can find my public key. And if in the DAD document there are more than one, I can use the fragment to tell you which one. Pay attention. This DAD is the DAD of who? Good. And the other one there? Credential subject? Good. Okay? Proof purpose. The issuer has a specific purpose, assertion method, and then the proof value. The signature on the wall credential. That's why data integrity proof, because you are essentially protecting the integrity of all the information that you as an issuer are putting in the credential. That's it for today. Tomorrow we can complicate also the proof section. If you remember the figure, this one, of a verifiable credential, metadata, claims equal credential subject, and then proofs. All verifiable credentials follow this simple scheme. Thank you and have a good evening.